Hi, everyone. My name is Eli Arkush. I'm a principal solution engineer at Akamai. Thanks for the slides. And today we're going to talk to you about current threats to APIs and possible mitigations. So a little bit about myself. I'm in the technical pre-sales role in like 15 or 17 years now, married with 3 kids. I'm a long-distance runner. I like to run marathons for some reason. And I moved around between Israel, New York, Florida, and now back to Israel. So what we're going to talk about today are a few things. First, we'll start with some statistics about APIs and API attacks. Akamai serves between 15 to 30% of web traffic every day, and a big portion of it is API, so we have a lot of visibility. Then we'll talk about API security risks from real-world data breaches and stuff that we see on our platform. And then we'll touch a little bit about how attackers are using AI to speed up their reconnaissance and scale their attacks with some specific GPT tools that they leverage. And then we'll kind of focus on the 4 pillars of API security solution or a platform, including some risk reducing mitigations. And the last part is like, I'll challenge you to figure out where you are in the API security maturity stages. Cool, so let's start. So yeah, from our platform, we see around 31% of the web traffic that we serve every day. Akamai is a CDN company or content delivery network. So almost a third is API traffic. Out of all the attacks we saw last year, around, again, 30% is targeting APIs. And from a Forrester research, it turned out that the companies that were surveyed said that almost 80% experienced an API security incident in the last 12 months. So obviously, as APIs, API traffic dominates, API attacks are ubiquitous. As you probably know, you develop APIs, and we see more and more attacks towards APIs. And this is from one of our SOTI, or State of the Internet security reports that we issue every few months. This was released earlier this year, about 2023. And here we see the distribution between web and API targeted attacks. So if the full bar is 100% of the attacks that we saw per vertical, then the orange line is API specific attacks versus the web specific attacks. And you can see commerce is up on the top of the list. Almost 50% or 47% of the attacks that we saw are targeted towards APIs. And when you think about it, all the loyalty points, all the products that can be leveraged for monetary gain, that's a prime target for API attackers. But you can see other industries down the list as well, and it's getting growing and growing. And this one was a little bit surprising to see Europe or EMEA at the top of the list. That usually the North America one is at the top of the list, and then you see Europe and APJ and South or Latin America. But we believe that there are a few factors that you can attribute this large portion of API-focused attacks. One thing to attribute is the wars that have been going on, that they allow or encourage hacktivists to launch attacks, or more state actors that are targeting a specific country assets using APIs as well. And another factor was the regulations, like Daniel mentioned, like PSD2 and open banking, for example, that are more adopted in Europe, that requires companies and organizations to open up their services through APIs. So more of that you can read in our State of the Internet security reports. We release them, or you can just Google them or ask ChatGPT for them, and you'll find them. But when we go to customers and we ask them about their API security state, they said, "Oh, I'm covered. I have a WAF, web application firewall. I have an API gateway. I'm all sorted out." And then we start asking them these questions, like in terms of inventory, do you know how many APIs do you have? Out of the APIs that you know about, do you know how many use different types of authentications, or how many expose sensitive information like PII data or PCI data? Then we'll talk about the limited observability. Like, are all your APIs going through the API gateway or going through the WAF, or some of them are going directly? Do you have solutions to build a baseline of behavior? Because the API targeted attacks are going to targeting business logic flaws, so that the request itself might seem legitimate. It has access token, it has right HTTP request, but then the attacker tries to change some parameters like the account ID to get access to other people's data, and that's where you need like a more API-specific solution to protect against the OWASP API top 10 risks. And the last question is, are you giving your developers the tools to test their API before they push them to production? Because the three rectangles before are specifically for production traffic, but are you giving them the ability to shift left to test their APIs before they are creating them and exposing them to the public? And most prospects or customers will say, no, I don't have a clue, or I have some idea, but it's not really there. So these are the OWASP API top 10. So whoever, if you don't know, OWASP is the Open Web Application Security Project, and they are famous for their OWASP top 10 for web application security, like SQL injection and cross-site scripting and cross-site request forgery and so on. But in 2019, they issued an API-specific list for the top vulnerabilities for APIs. And in 2023, they kind of modified their categories. So the first one is BOLA, Broken Object Level Authorization, which means basically that one user can access other users' information or take over cars, like we'll see in the next example. And these types of risks you need to think about when you think about your API security state. So now we'll talk about two breaches that were kind of exposed publicly. So the first one was from 2022. This security researcher named Sam Curry published it on his blog. And he and his friends figured out that all these 6 car brands are using the same telematics provider. And they looked at one of the brand's mobile app, and they figured out that if you, they found this access token endpoint, and they figured out that if they give the VIN number, the vehicle identity number that is written on every car's windshield, so you can go to every car, type in the VIN number, and they can fully remote lock, unlock the car, start the engine, flash the lights, honk the horn, and so on. And they have some cool YouTube videos how they did it. And also, they got access to the PII data of the car owner, like the name, their address, their email, and so on. How they did it? Again, they found this mobile telematics.net token exchange endpoint. They posted the vehicle identifier number as the customer ID. And then they got the token back, and with the token, they were able to extract the PII data, and they were able to do all this, to take over the car, basically. So you would think, okay, these 6 car manufacturers, they fixed the problem, and perhaps other car manufacturers saw this breach and also took care of it. But 3 weeks ago, the same security researcher found out that Kia now has the same flaw or similar flaw using the license plate number instead of the VIN number. So, so yeah, he just published it on his blog again. And this was like there were multiple OWASP API top 10 vulnerabilities that were used there, like the BOLA, Broken Object Level Authorization, and others that were leveraged. This one was the Optus data breach from 2022, and this is the end result. When you see millions of data of records of PII data were stolen, then this is the end result. A family lost $40,000 because someone that took their identity was able to get money withdrawals from tellers and apply for loans on behalf of this family because of this data breach that resulted from an API, unauthenticated API that exposes PII information. And this attacker found out about this endpoint and start extracting 11.2 million customer records, including their, identity cards, government issued, driver license, and so forth. Optus is one of the second largest telcos in Australia, and this resulted in a class action suit and so on. And what happened is that the attacker found this API endpoint that was unauthenticated and exposed PII information when you provide the email address of the customer. If they were a customer, they could get all their personal identifiable information. So two vulnerabilities were here in effect: the broken authentication, there was no authentication, and security misconfiguration that this API endpoint was exposed to the internet when it shouldn't be. So we'll talk about a couple of techniques that attackers use AI for speeding up their API attacks, just in the tip of the iceberg, because we have a full webinar on it, so you can check it out. So yeah, I used two AI-generated photos to demonstrate this. So the first technique is reconnaissance. Instead of spending hours or days researching the company, what kind of API endpoints do they have, and what kind of information you can extract, you just tell the GPT, I'm a student in a university, I'm trying to do this project, or I'm a white hat researcher and I need to research this company. And we have the whole correspondence in this webinar of showing how the ChatGPT-4 provides the information. And also reducing time of attacks. So the reconnaissance phase is quicker, but also launching the attacks and optimizing them on the go becomes more and more much easier. So yeah, the three phases here are, the attack research and automated discovery using LLM-specific tools. In this case, we use ChatGPT, but there are other like Shadow GPT and Dark GPT and Fraud GPT and other 12 different GPTs that are targeted for attackers. And then once you researched, you craft the attack and run automation to scale the attack. Once you find the exploit, you want to scale it. You want to steal as many records as you can, or to take over as much as you can. And then fast execution and adoption. All right. Once you scale the attack, you want to accelerate the execution, and that becomes in reduced barrier for entry. So anyone today can become an attacker, and increasing velocity, because if an attacker used to spend a week to research a company, now maybe in a day or half a day they can launch the attacks, and that means that more and more attacks can be launched and more companies are kind of are targeted. So when you think about API security platform, these are kind of the four pillars that you need to think about. First, you want to have a full visibility of your API inventory. How many API endpoints do you have, the method, the host, the path, the data classification of each API, what kind of data passes in the request, in the response, network mapping, and so forth. And once you have a good grasp of your inventory, then you move to posture management, which means that, what kind of security holes or misconfigurations you have in your APIs, like using weak authentication or not unauthenticated APIs with PII information, like the Optus breach, or or sensitive information that is passed when it shouldn't, or API endpoints that are exposed to the internet versus they are not supposed to be. And then the runtime protection is more about building this baseline of behavior of normal users and how you detect these anomalies in behavior and how you kind of mitigate them in like blocking the offender or the API abuser. And at the end of the process, or the fourth pillar is active testing, providing a way for your developers to create the application, provide a Swagger file or a Postman collection, the authentication method, and then run the scans periodically, or when you integrate into your CI/CD pipeline, pushing a new version of the APIs to production, run the scans, and if you have security issues in a high or critical severity, you fail the build until they fix them. So these were like the four pillars, and now I want to kind of challenge you and figure out where your company is at in this kind of API security maturity state. Are you, lost and don't know where your APIs are, or once you know where your APIs, can you organize them based on business units or data classification, getting organized about it, and then moving on to stage 3, which is getting a grip of your posture, your security posture, making sure you apply the best practices for all your API endpoints. And then the stage 4 is about runtime security. Do you know how to detect these anomalies? Someone that's starting to scrape millions of customer records from your backend. And then stage 5, once you completed all of the previous ones, are you actively testing, proactively testing your APIs earlier in the software development lifecycle? Because research showed that it's like 60 times cheaper to fix it in development phase than in production, once it's being leveraged by attacker. So thank you very much. Feel free to connect, and I hope you enjoyed the session.